Week's lab involves using a new software called Stellarium. Well, new to you anyway, I imagine. And using that software to zoom in on the planet Jupiter, make some measurements of the orbits of its moons in order to determine the mass of the planet Jupiter. So on the right-hand side here, we have the instructions for the lab called WeighingJupiter. There's some information in the beginning about the theory of how you're calculating that mass. And so, namely, we're looking at this equation right here, equation number 1. A is the average distance of the moon from the planet, and P is its orbital period. And so we want to get those two numbers to estimate the mass of the planet. Now, if I fast forward here to the tables at the end of the lab handout, this is the information that you're ultimately going to collect and to calculate. And for each moon, you can get its orbital parameters and determine the mass of Jupiter. So you find this series of things and ultimately use the equation to calculate what the mass of Jupiter is. You'll do that for all 4 moons, so you have 4 different measurements that should be about the same value. And then you can average them together to get your final answer for what the mass of Jupiter is. So in order to do this, we need to know a little bit more about Stellarium, how to navigate around and explore within Stellarium. Now, Stellarium is an accurate simulation of what the sky looks like that is completely customizable. The first thing we want to do is actually locate where Jupiter is. So I have Stellarium opened here on the side, and so when it opens up, it should look something like this. The S refers to south, so it's facing the south. The background here you can customize. There's lots of customizable features. We're just going to focus on, for now, the ones you need to know for the Jupiter lab. Okay, so the bottom left, you'll see it says Earth, Concord, New Hampshire. So that's where we're set. You can change that. It might not come set up to find your current location, and you'll need to plug it in. So when you hover over to the left-hand side of the screen, you get this menu, and the top option here, the star, is the location window. And that's how you select where you are. Now, I've got it set to Concord. That's one of the preset locations. As long as you're pretty close, the sky will look as it is. It's not that critical for what we're doing since we're zooming in and just looking at Jupiter, but you will eventually want to have it set for your specific location. You can put in the latitude and longitude, so you can look up your exact latitude and longitude if you want it to be very specific, or you can select from this list. You can also move the arrow around on the globe. So use the location window to set your location. And then the pictures that you see will be what they would look like at the current date and time. Now below the location window, we have the date and time window. And so I've brought that up here. Let's see. Because we're going to use the information in the date and time window in order to figure out the period of the moons going around Jupiter. Okay, so that's the date and time. Tells me right now, May 26th at year 2022. Okay, so I'm skipping over the sky and viewing options window, but now what we need is the search window. And the search window it gives me as one of my options Jupiter, but I can also just type it in, and whatever you type in, it'll start to look for it. So I've found Jupiter, and once you click enter, it will center on Jupiter. And you see the little red lines, that tells you it's centered here on Jupiter. For our purposes, we don't care about the image looking like we would see it. We want to zoom in to where Jupiter actually is. So the atmosphere and the ground, they're just in our way. So I'll hover to the bottom of the screen, and here we can choose lots of different options. The first ones are for constellation labels and lines and pictures. Then we can change the grid. We don't need any of those options here, but we can get rid of the ground. So if you click that button, the ground disappears, and we can get rid of the atmosphere. And so this is what the sky would look like if there was no ground and no atmosphere. So basically if you were above the atmosphere just looking out into space. And we would see, at this current time, Jupiter, Mars, Venus, the Moon. It's sort of an interesting time because they're all kind of in the same location of the sky, just by coincidence. Then, for me, using a MacBook, the two-finger swipe down will zoom in. If you have a scroll bar, like a mouse with a scroll bar, you might be able to scroll to zoom in. But we want to zoom in, and as we zoom in, you'll start to see the moons appear in their current locations. So we have centered on Jupiter, we have Io, Europa, Ganymede, and Callisto. And here's where we'll want to make measurements. All right, so I've located Jupiter. Then we need to determine the scale factor. Now the scale factor will tell us the relationship between how far apart things are on our screen and how far apart they are in real life. And we'll use the size of Jupiter to set that scale. So in the instructions, it tells us the actual size is 140,000 kilometers. So this distance across Jupiter in real life is 140,000 kilometers. The tool that you'll need for this lab, aside from the computer, is a ruler. So then you'll put your ruler on the screen and measure how many centimeters across Jupiter is. And so it's important when you get to this point that you're not zooming in or out any further, because once you zoom in or out, you're changing the size of Jupiter on your screen, so you would be changing the scale factor. So if I zoom in to a point that I'm happy with, I stay at that point and then I measure the size of Jupiter. Now your question might be, how far do you want to zoom in? Well, you need to be able to see the entire orbit of the moon. And I'm just going to look at Io. So here, let me click over here. Here, what you'll notice is that Io will stay on the screen as I fast forward in time. So if I had zoomed in too far, Io would leave the screen at some point. So let me zoom in a little bit further here. Oh. Need to recenter on Jupiter. If you click off of Jupiter by accident like I did, you can recenter. On the bottom of the screen, there's an option here. Oops, not that one. To center. Oops. Sorry, clicked the wrong thing twice. This option here where the arrows are pointing in will center my screen back on Jupiter. Okay. Now I've zoomed in too far so that the moons are actually off the screen. So I can't have my scale this big. I need to make it a little bit smaller, small enough so that Io always stays somewhere on the screen. And then I can measure its orbit. When you get to the planets that are farther away, you'll have to zoom out a little bit more so you can see their orbits. So I'd probably have to go to here to measure Ganymede. But we'll just look at Io first. So I can zoom in, let's say, to about here. Now that I've established this, I'm not going to zoom out or zoom in any further until I get to the next moon. So I'll measure the size of Jupiter on the screen. I know what it is in real life, and that will tell me how to translate between centimeters on the screen and kilometers in real life. Step 3 is to find the semi-major axis of that moon. So here's Io. Its semi-major axis is its average distance from the planet. And since we're sort of looking at it in a two-dimensional way, we need to figure out when is it its furthest point from Jupiter on the screen. So we're looking at the orbits kind of from the side. So if I scroll, hour at a time, oops, we need to center on Jupiter. There we go. Stay centered on Jupiter. If we fast forward an hour at a time, you can see its position changes. Now, in your judgment, whenever you've got Io about its furthest position, you measure its distance. That's the semi-major axis. So let's say I judged that to be about right here. You'd measure the distance from the center of Jupiter to the center of the moon, and you'll record that distance as A. And so in this formula it would be A in units of centimeters. S is the scale factor. You multiply those together, divide by this number here, and you will get the actual semi-major axis of the moon in astronomical units. So you have that just by measuring with a ruler and doing the calculation. Then you need the orbital period. So step 4 is to find the orbital period. And for that, you need to watch or fast forward through one orbit of the moon around Jupiter. Okay. So to time that orbit, you need to have a good starting point. And the instructions say to go to a day that's near the beginning of the month, because that will make the calculation more simple, because the whole orbit will be within 1 month. And so you won't have to factor in the changeover in months. You can just subtract the number of days. And so here I'm at the end of May. So I'm going to fast forward until we get to, and I've gotten off center, so let me recenter it. It keeps getting off center because I'm clicking back and forth between these documents, and so it's not staying centered like I should. You hopefully won't have this problem. But I'm going to fast forward. Actually, I'll do a couple days ahead, and I'll get to June. So now I'm in June, and I'll pick a starting point that I can come back to so that I know it's made one complete revolution. So what I'm going to choose as my starting point is Io right in front of Jupiter. So Io is right here. And so I'm on June 2nd, 17 hours, 50 minutes. You don't really need the seconds. Won't change your answer very much. So June 2nd, 17 hours, 50 seconds. And you'll record that start time here, days, hours, and minutes. 2:17:50. That's my starting point. And the ending point will be, recenter, whenever Io returns to that same location. And so it goes out to its furthest extent on the right. It will come back through, move behind Jupiter, go out to its furthest extent on the left, and then it will come back to be in front of Jupiter. And I can mess with the minutes here to get it perfectly in the center as I can. And then I'll record this new time. So it's 2:12:21. It takes about 2 days for Io to go once around Jupiter. You'll be a little more precise than I am here, recording the start time and then the end time. The period then can be found from this calculation. You subtract the days, you subtract the hours, you subtract the minutes, plug them into this formula here, and it will convert it into the orbital period in units of minutes. Then use this formula to take it from minutes into years. You have your two numbers at that point, semi-major axis, orbital period, and you can calculate what the mass of Jupiter should be. Okay. Once you do this for one moon, it's the exact same steps to do it for the next. Take time to make sure you get the semi-major axis measured precisely, so noodle around with the time until you can, and hold your ruler up to the screen to verify that the moon is as far as you can get it from the planet. Then when you get to the timing, find a starting point. Either pick when the moon is in front of the planet, or maybe you can start from when it's at its furthest extent. Either way, make sure you record one full period. So as I did it, I started with the moon in front of the planet, which I can see the moon in front of the planet. I watched it go out and then back behind the planet, out to the other side, and then return to the front of the planet. That's one full orbit. A common mistake is to only get half an orbit. So maybe you get it in front of the planet and then you come back and then record when it's behind the planet. Or if you step forward too much time, maybe if you, instead of going hour by hour, you click day by day, you might miss when it returns to its first starting point, and you'll record 2 full periods instead of 1. So take care when you make these measurements so that you're recording exactly 1 full period of time. Record days, the day, hour, and minute of the starting and the end point, and then the rest is calculation to get to your answer for the mass of Jupiter. All right, so this is the downloaded version of Stellarium. I just downloaded this today to make sure that the version that you download is the same one that I've had. The controls hopefully will look the same to you, although it might be slightly different if you're using a PC versus a Mac. If you run into an issue where what I'm doing here doesn't look like what you're trying to do in your computer, just reach out to me and I'm happy to set up a Zoom call to take a look at what you're looking at, and we can figure out how to do the step that you need to do.